To decide whether a function has an inverse or not, we're going to use something called the horizontal line test. So that is, we say a function passes the horizontal line test if every horizontal line drawn in the plane intersects the graph of the function at most one time. So let's look at that here in example 1. This is the graph of the cube root of x minus 4, then plus 5. Does this thing pass the horizontal line test? And the answer is going to be yes. By just looking at the graph, any horizontal line that you draw is only going to meet up with the graph once. So if I look at this horizontal line, it hits the graph here just that one time. We could do this all day, but I see that every horizontal line I draw, if I focus around where the function is, it only meets up with the graph once. So that was here, here, and here. Now, of course, this graph keeps increasing forever. It's decreasing if you go in the other direction. So if we were to expand this graph out, the same thing would hold true. No matter what horizontal line you draw, it's only going to go through the graph one time. So that's why I wrote f of x passes the horizontal line test. And we have this fact. If the function does pass the horizontal line test, it must have an inverse. And if this is the case, we say that the function is 1-to-1. So if something passes the horizontal line test, we would call this a 1-to-1 function. So in terms of solving for the inverse, let's figure out what it is. My original equation is y is equal to the cube root of x minus 4 plus 5. It must have an inverse, so if I set that equation up, it is x is equal to the cube root of y minus 4 plus 5. So this thing here would be the inverse. And I'm claiming that this actually does exist. It's our job to solve for it. So what I'm going to do is subtract 5 from both sides. I get x minus 5 is equal to the cube root of y minus 4. My goal is to solve for y, so I see I can cube both sides. The right side is really simple. Cubing the cube root leaves me with y minus 4. And on the other side, I have x minus 5 cubed. Since my goal is just to get y by itself, I'm just going to leave that as x minus 5 cubed. My last step is to add 4 to both sides. And I have my equation. X minus 5 cubed plus 4 is equal to y. This is the formula for the inverse function. So I'll write that as f inverse of x is equal to x minus 5 cubed plus 4. So to start with, we ask the question of, does this thing pass the horizontal line test? And if it does, we can find its inverse. So we looked at its graph, looked at a bunch of horizontal lines, decided each one only goes through the graph one time. It was at this point where I said, okay, if this is my original function, it makes sense to write what the inverse is equal to, and therefore we were able to solve for its equation, and I wrote it here at the end. So now that we have an example of one where, okay, I looked at the graph, it does pass the horizontal line test, there was an inverse, what about this graph? F of x is equal to x squared plus 4. Does this thing pass the horizontal line test? Is it true that every horizontal line that I draw passes through the graph at most once? So if you start with a horizontal line down here, well, it doesn't go through the graph at all, but that's okay. That's definitely at most once. If you say it doesn't happen down here, no horizontal line down here is going to go through the graph. But if I chose, let's say, I don't know, this horizontal line, okay, that one actually goes through the graph twice. That's more than once. There's a spot here and a spot here. I can actually write down what those 2 points are equal to. The one on the left is -1, 5, and the one on the right is 1, 5. So no, this does not pass the horizontal line test. So here I just jotted that down. Just by looking at the graph, we only had to find one horizontal line where this went wrong. And once it goes wrong once, the answer is nope. And that means this thing does not have an inverse. So another statement would be, this thing is not 1-to-1. And what that means is I have this one y value of 5, but it goes to two different x values, so there's not this one-to-one correspondence between your x's and your y's. So why actually does this not have an inverse? Like, what's the problem? Well, you could still try going through this process where, well, my original function is y is equal to x squared plus 4. Well, couldn't you just say, oh, well, my inverse is x is equal to y squared plus 4. Like, what's going to go wrong with this process? You would start by subtracting 4 from both sides. That would give you x minus 4 is equal to y squared. Okay, here I want to get rid of the the exponent by taking the square root of both sides. And on the right side, you would get y. On the left side, you get the square root of x minus 4, provided, and this is the problem, that you put a plus or minus. There's actually two solutions. You get that, well, y could be the positive square root of x minus 4, or y could be the negative square root of x minus 4. But for this process to work, there has to be exactly one equation, and this process gave us two, so that is an issue. And the fact that this happened meant that there's no one inverse for this function. A second way to look at this is, all right, if you draw a horizontal line and you get 2 points that lie on it, your inverse function is the thing that switches your x and your y values. This is x equals -1, this is y is equal to 5. If you switch those around, you get the point 5 comma -1. So that's 5, -1. All I'm doing is switching my x's and my y's, and that gives me this brand new point. Here, if I do the same thing, if I switch the x and y's on this point, on the inverse, you'd have the point 5, comma 1. And here's the problem. These 2 points would have to be on the same function, but you can't have one point directly above the other. This thing doesn't pass what we call the vertical line test. Here's what's really going on. If a horizontal line goes through 2 points, its inverse would have 2 points that lie on a vertical line, but we've already decided that you can't define a function, so one point is above the other. So this work ultimately was unnecessary for the problem. I just wanted to examine this just a little bit more deeply, but all you really need to do is look at your graph and say, does it pass the horizontal line test? If the answer is no, then you don't even have to consider this process whatsoever. There is no inverse on the domain of this function.